Thanks for inviting me. Today I want to talk about building smart AI and how a naive application of deep learning can actually get you into deep trouble. And I don't mean to sound alarmist, but I think the point should be made that with any technology, it can be used for good or evil, right? Nuclear energy can be used to illuminate the world or blow up the world. And so I want to speak to our responsibility as data scientists to be taking these tools and methodologies and applying them in a smart way, and not just getting seduced by the sexy new thing that's out there. So I like to take a step back. I probably don't need to explain this to this audience, but why is AI so excited? Why should we care about it? From my perspective, AI has the potential to do two things really well. One is to automate repetitive tasks and be a huge time saver. And the other, which I think is really exciting for me as an economist, is the ability to augment human decision making. And the fact of the matter is, there's this long line of economic research called behavioral economics. And what it's found is that we as humans, we're really bad at making decisions. We suffer from countless biases, overconfidence bias, hot hand fallacy. We actually make the wrong decision often over and over again. And my view is that algorithms don't suffer from decision fatigue. They ultimately are unbiased when you train it with the right types of data. And so I believe the real potential of AI is to augment our decision making and to help us make better decisions in a wide range of fields. Think about any job that you do as a lawyer, in education, as a doctor, you're making decisions constantly. I think if you apply AI at the right point in time and you render that information to the right person, the right point in time, in the right way, you can actually influence them in a positive way to help them make the right decision. So it has potential to really influence countless fields. So I'll give you my perception of the history of data science in 30 seconds. And this is a highly simplified version, but I'm trained as an econometrician. It was a little bit, I think, unusual actually in data science circles. And as I've surveyed the literature and seen what models have become in vogue, I've seen this trend, right? We start, I think really, 90s was sort of the heyday for, or even earlier, heyday for statistics and econometrics. Those are relatively transparent models, linear models, logistic regressions, things of that nature. Over time, we really shifted towards machine learning, right? And the newest models were support vector machines, random forest boosted trees. That got really popular. And now, what is it that everyone's talking about? It's deep learning, right? We've gotten really excited about the potential for deep learning to do even better than all of those previous models. And the fact of the matter is they do perform, for the right tasks, they perform better, right? I think that's pretty undeniable. But as we've shifted from these transparent models, from statistics and econometrics to machine learning to deep learning, I think we've actually lost something in the process. And I think those two things, first, is causal inference. So people may not realize this. As an econometrician, I sit there and I wonder, well, what is it that makes me special? Why do I still exist in a world of data science that seems to be very dominated by engineers? The one thing econometricians are taught very well is causal inference, right? It's a really hard thing to do, to demonstrate that X is causally related to Y, and it's not being driven by Y, and both variables aren't being driven by a third unobserved variable. It's hard to do unless you can run experiments, which many of the people in this room may be able to do. If you're doing a retrospective study, causal inference is very hard to do. However, we've shifted away from that. I think over time we've said, you know what, the problems we're encountering in technology, we don't care about causal inference as much as being able to predict an outcome. We don't care if the things we're measuring predict it. We just want to know, hey, is someone going to click on the buy button? And if they are, we can handle that differently than someone who we think is unlikely to be engaged. But I believe that constitutes the why. Why are two variables related, or are they actually causally related at all? So I think in this shift, we really lost the why. And I'll give you guys a couple examples of why losing the why is actually problematic and something to be cause for concern. The second, and I think no one would disagree with this, transparent models. The fact of the matter is, with all of those statistics and econometric models that I was trained in, if you give me enough scratch paper and pen, I can replicate those results. It's not fun, but for those of us who can do some matrix algebra and matrix math, they're all transparent. I can tell you exactly how that math was done to generate whatever solution you guys are seeing on your computer screen. We can't do that anymore, as we've shifted to those boosted trees, towards random forests, and especially towards any number of neural nets. We've trained the machines because we know these algorithms perform better than those transparent models, but we can't replicate them. And in many cases, we can't even explain why it is the machine came to the solution that it did, right? And I think that's cause for concern because I believe that represents the how, which is as we shift to black boxes, it becomes increasingly difficult to peer under the hood and to understand, well, in what direction are these variables related? Are we looking at some linear relationship, something U-shaped? We just know that, again, we're predicting better, we're happy with that, but we don't understand what variables are influencing that outcome in what direction. And so I think losing the how is actually really important. And so for the next, I guess, 15 minutes or so, I'm going to just keep banging you guys over the head with examples of why this is important, why you guys should care as data scientists. I'll back up, probably not necessary for this crowd, but I always like to give a very brief primer on deep learning because you never know where folks are coming from. So these sort of models, when we're trying to estimate the price of a home, right? We have a number, that's our target, is price for a home, and we have a number of features that we insert into the model. And if you think about a home, that home may have attributes like the number of bedrooms, square footage, or where it's located and what sort of neighborhood it's in. A very simple model, like a linear model, logistic model, what those will do is map directly each of those variables to the outcome, and it's going to assign weights. Each variable gets a single weight, right? And it basically minimizes the cost function so that those weights generate that estimate as often as possible, right? Really simple model. When we move to a deep learning model, what we add are layers of neurons. And it says, I think we got smart in that we said, you know what, there might not be a linear relationship between square foot and price. There might be a interrelated relationship with the number of bedrooms. Square foot might interrelate with the number of bedrooms. That might interact with the location of the home. So we add this layer of neurons, and we now have 12 different relationships here. This is a single layer of neurons. And what we know generally is with enough data, that neural net is going to estimate home price better than the linear model. People don't actually realize this in and of itself is actually a neural net. It's just a single layer neural net. There's one layer here, right? The nice thing about this is especially for specific tasks like image and audio work, those neural nets are far more effective than anything that we as humans can do, right? So if you imagine in a matrix, when you have a diagram that maybe has 8 pixels by 8 pixels, and now you have 64 pixels total, and each of those pixels can take on a different value ranging from 1 to 255. You would feed that to a neural net. We don't have to hand code features. You could feed it to a neural net, and the neural net doesn't know exactly what it's seeing. All it sees is pixels in specific sort of positions, right? And by looking at the relationships between the pixels, it starts to recognize lines, and by putting lines together, it recognizes shapes. And that's how we can train the neural net to identify something like a hot dog, right? So I stole this from the Silicon Valley app that everyone's probably, folks have probably heard of. But you can actually train the neural net with enough labeled data on hot dogs. You can train it to identify a hot dog or what isn't a hot dog. You can, however, trick the algorithm by doing things that are maybe a little bit less common. Side note, it's definitely awkward when you're taking photos at home of bananas with ketchup on it and your roommate comes home. But the bottom line is the neural net, this is the key point, is the neural net doesn't know what it's seeing, right? It's a machine, but what it sees is pixels in specific combinations, and you associate that with a label or an outcome. And it says, when I see these pixels in frequently observed patterns, I know that's a hot dog, right? But it doesn't intuitively know what it's seeing. So before I get into a couple examples of why this may be problematic, I'll just offer up the caveat. I'm an economist. I wasn't trained with these models, though I have worked with them before. I'm sure there are some who at the end of the talk will say this guy is a dinosaur. He's just bitter because he's going extinct, and there's lots of new models that have replaced the models that he grew up with and loved. And it could be true, right? That may be the case. But I submit that as data scientists, we actually have an obligation not unlike medical professionals. And that obligation is to first do no harm. And I actually think there's a lot of potential to do a lot of harm if you take a neural net and get really excited and you apply it to problems where it's not applicable. And John Mora actually spoke to this earlier, which is sometimes just because you're dealing with YouTube data, you shouldn't necessarily say, oh, there's images here. I know exactly what I can do with images. There's all sorts of packages out there that allow me to classify images. Sometimes the labels in YouTube data can be much more effective than using images or videos. So what I'll explain, and I'll offer very specific examples from my career, is that if you ignore the how, you can actually reinforce existing biases when you're not digging in and drilling down and trying to understand the relationships that are present therein. And if you ignore the why, you can ignore causal relationships, and that can actually cause you to make a lot of, to cause trouble when you're trying to influence an outcome, when you're trying to not just predict, but when you're trying to optimize something. So 2 examples. One, I was the chief analytics officer for a company called Evolve. Evolve, I believe every business should start by solving a problem. In this case, the problem was recruiting. If anyone has posted job recs online, what you find is that you get hundreds of applications, many of which aren't qualified. It takes recruiters tons of time to filter through those applications. The studies have shown that recruiters spend an average of 7 seconds on every resume. It's not a lot of time. And as bad as we are at making decisions, as behavioral economics says, we're actually much worse at making decisions about people, right? We're actually very bad. The studies have shown what happens during an interview is typically you walk in the door, I spend about 30 seconds to a minute sizing you up, I make an opinion, and then I spend the remaining 29 minutes telling myself why I was right? So we really wanted to influence this. We saw there was a big opportunity to help bring algorithmic thinking and augmented intelligence to recruiting. So our solution was we are going to take psychometric assessments. These are assessments we capture at the point of application. We'd ask you a bunch of questions about your personality, knowledge, skills, abilities, what makes you tick, right? And then we combine that with downstream HR data. We want to understand, okay, you got hired, how'd you do on the job? How long did you stick around? Were you present or absent on most days, right? We're capturing performance outcomes that the recruiters would never, ever see. Combine that in a very large data warehouse. We apply workforce science, which is just a fancy language for personality tests, kind of industrial, like psychology. And then we apply predictive analytics. And what we ended up with was a color-coded score, green, yellow, or red, that would tell the recruiter, this is how likely this person is to succeed on the job. Higher the greens stay longer, they perform better. So side note, in the course of doing the work that we did, we got the opportunity to study really interesting things about employees that recruiters, for example, would never ever get access to. And I will say this, my job as chief data scientist, I'll back up a slide actually, was to fine tune the algorithms and to make them as predictive as possible. And there are 3 hallmarks for success, right? Number 1 is I wanted it to be a high fidelity signal. People are constantly, you ask someone about their resume, I think 70% of resumes have some sort of lie in them. So people lie on the resumes. We want a signal that can't easily be gained. When you ask someone, is it important to come into work on time, yes or no, everyone knows the answer to that question. So that's number 1. Number 2 is I want a signal that's highly predictive. I want it to be predictive of outcomes, right? We need to make sure that we're tying it to outcomes. And number 3 is survey or resume fatigue. If I ask you to jump through a bunch of hoops and it takes you an hour and a half to get through the application, you're probably going to drop out. I've now lost a potential job applicant, right? So I want it to be quick and easy, high fidelity, strong signal of outcomes. Along the way, one of my analysts had an idea, and he said, you know what? I think a better way to assess someone's job fitness isn't to ask them about the resume. It's maybe to understand a little bit more about their technological proficiency, about their laptop. So we started digging in and looking at typing scores and whether you could answer questions about technical proficiency. But then he had a really clever idea. And he said, we were gathering in the course of people applying for these jobs through our platform. We didn't even realize we were gathering their browser, right? And what we found, well, actually, before I share the results, show of hands, try not to game the system. Show of hands, when you open up your email this morning, who used, let's see here, Firefox? Firefox users, raise your hand, okay? Like 4 or 5. Who used Internet Explorer? It's always low in technical conferences and much higher in business conferences. Who opened up Chrome? I'd be in that one. And who opened up Safari? Okay, cool. We got like 3 or 4. All right, so the answer is congratulations to those who raised their hand with Firefox or Chrome. You stay on the job 15% longer and you perform 19% better. Sorry to the handful of Chrome users here. Safari users here. But the answer is not that you should go and install Firefox or Chrome on your computer. What we found was that we were looking at something we think was initiative, right? Being a little bit nonconformist, those browsers, as easy as they are to install, they show something about you. The fact that they're not default and that you took the time to install those browsers shows us a little something about your productivity and how you're likely to perform on the job. Right? But for me, this is pay dirt, because what we realized, we had stumbled upon this signal that was highly predictive of outcomes. This is almost as predictive as the rest of the assessment. It took no time to submit because you didn't even know you were submitting it. And it was hard to game. In fact, impossible to game. Unless you were on a friend's computer and you knew we were looking at this, there's no way to game the assessment, right? We were getting this in a fraction of a second, and it was highly correlated with outcomes. So I'll share the punchline, which is we studied this, we did some additional analyses, we talked to others at our company, and we decided not to use this, right? This incredibly powerful signal, we decided we were just going to pass, which is thankfully one of the reasons I can share this with you guys today. So in the interest of making this interactive, I'll let you guys guess. Why is it we took this signal and decided not to use it? Yep.
Was this indicative of something else, like older users were applying using Internet Explorer? In which case is that just leading out based on age?
That is, you are the first person who's gotten that correctly on the first try. So congrats to that gentleman. We'll talk, are you a data scientist? Well, yeah, sorry, I'll repeat. It was great. So he said, you might be measuring something else unintended, like, for example, age, right? If older individuals are the ones that aren't updating their internet browser and switching to Chrome or Firefox, you might be accidentally ageist, right? And that is, I'd say there are two reasons why we didn't use it, to be fair. The more obvious reason is that it's kind of creepy. And if people found out about it, you know, we have there's kind of black and white and then there's gray, but we thought this was creepy enough that it was somewhere in between, and we thought if people found out about it, they'd be worried, and that we didn't want that to get out. But more importantly, when we did a lot of additional tests, what we found was that it was actually a highly ageist construct, that we were unintentionally, if we had deployed this for production, we'd be discriminating against older individuals who just weren't installing that. Good job, by the way. That's actually, I've given this talk a number of times. So my point is this, though. With the models that we were running, and we were running a wide array of models, but some of them were just simple logistic and linear regressions, we were able to understand the coefficients, right? We were getting data about age, sex, race, things like that, and then we were looking at how that was related to this variable, right? I worry in the case of a deep learning model whether you can explore that. So let me give you another example. Let's say you're using videos. And by the way, there are companies doing this right now. They're capturing video data. They ask questions of applicants. The applicants respond. 2 to 3 minute clips of those responses are then analyzed by some sort of deep learning algorithm, right? The algorithm is trained based on voice cues, intonation, inflection, as well as what you're saying. They do a lot of transcription and NLP. They're also trained based on visual cues. They're trained to be able to identify people who are confident and conscientious versus people who are maybe insecure, right? And those are the things that they believe they're ultimately correlating with outcomes. You give them a lot of data on who was promoted, who's really succeeded at this company. And we connect it to all those video interviews that were captured at the point of application. And we ask, which are the ones, based on the interview, that we think we can predict will do well in this company, right? And there's no question the algorithms can do that, right? They can absolutely predict who's going to succeed. But what concern would you have about something like this? Jump in. What's the problem? Yeah. Go for it.
It's the same as see, there could be underlying indicators that, like skin color or gender, which might affect those.
Exactly. Exactly. Think about it. You train it based on data of representing, say, who was promoted at a company, right? Well, what if the people that tend to get promoted are white males, right? And the folks that maybe stick around but don't ever get moved up, those are females. And what if the folks that tend to get shown the door are minorities, right? This is a hypothetical. Those companies, I believe, do employ some ways of trying to test that. Now, the nice thing is they can test things, for example, that are obvious in the data, right? And obvious EEOC, when you submit those applications, you indicate your race, your gender, your age. Those things are things they can detect. But let me ask a hypothetical. What if there's a long line of research that finds that people are biased in favor of those that are relatively attractive, right? Sad news for someone like me, but the fact of the matter is, no, the bottom line is that's not something you submit, And you could go through these photos and evaluate them, but I don't think anyone is doing that. And I would think we would all agree that that is a form of bias that creeps into your algorithms and causes you maybe to pass on people who might otherwise be great fits. Cool. So second example. That, by the way, I just want to back up. That's the how. That's when you don't dig in, you don't understand how the algorithm is operating. A very naive application of, say, some sort of deep learning can actually lead you in a really bad direction, right? You can be biased against all sorts of individuals that you wouldn't want to be biased against. Second example, again, every company should solve a problem. The company that I've co-founded is called Rapport Boost, and we're helping to provide emotional intelligence to bots, but at first we're very focused on live human agents. The problem with bots, has anyone interacted with a bot? Raise your hand if you've interacted with a bot. What was the general, what was your experience? Good, bad, how was it?
It's fine for the simple stuff.
Yep. A lot of time was being wasted. Yeah, we hit, bots aren't there yet. That's generally what we hear. I think in the short term, you're going to see a combination of human plus bots, and then eventually you'll see bots becoming more dominant. But messaging and chat is a very difficult medium because you're missing all those physical cues. 93% of communication is nonverbal. All of that's out the door. All you have are two thumbs or just your keypad, right? So bots struggle to sell effectively. They don't reflect the brand identity. They're not personalized to adapt the user. That's why we founded Rapport Boost, is because we believe in conversational commerce, but we think that a lot of that conversation, we're naturally social human beings, and so we like to engage with one another. We like to build rapport. Side note, if anyone here is using chat in any way, shape, or form, we would love to chat later. But I will say this. So we have this solution. Same solution as before, by the way. I'm a one-trick pony. Take chat data, KPI outcomes, feed it to a large data warehouse, apply natural language processing, machine learning, generate outcomes that basically tell companies how do you engage with customers? What's the best way to engage with them? Good news for us is what drives sales conversion when it comes to conversational commerce isn't the topic of the conversation. It's not the demographics of the visitor. It's really the conversation you're having. 62% is driven by effort, friendliness, emotion, responsiveness, things that I would consider to be really human skills. That's EQ. We generate lots of interesting insights like what's the proper formal language that you should use. We find there's almost always a U-shaped curve, right? If you're too informal, you're sounding like a millennial that's trying to sell something or engage with customers, not good. If you're too formal, you sound like a bot. We see that problem more frequently than the other. Everyone types up and pre-scripts these responses, and they're just too robotic, and people get turned off by that. So this is the fun stuff. Early in the evolution of our algorithms, we had trained a model. We trained it based on customer satisfaction. This is important, right? Large e-commerce retailer, about 200,000 chats. And we said, can we predict good customer? They were very focused on providing a good, superior customer experience. We trained it based on CSAT. And then we basically released it. We had a demo we had built at the time. And we said, OK, now we're going to use that algorithm, that classifier, to coach the agents and to tell them what they're doing right and wrong. It's going to score conversations, tell them how they can improve. So read, I'll give you guys a second, though I'm going to run a little low on time. Read the conversation. Give me your assessment. Someone jump in. On a scale of 1 to 100, where would you score this conversation? No wrong answer. Jump in. Go ahead.
Started off high, and then like the last response,
Yep.
kind of took it out.
Not good. Yeah, the why is it so hard is probably a good sign. Give me a score just for the sake of
40.
Oh wow, look at that. You almost you nailed that was what the algorithm returned. It says what's the likelihood this is going to be good or bad? 40. Most people guess lower, but I'm sure it's seen worse, right? But here's the really fun part. So if you were a chat coach, now pretend you're a chat coach, you're looking over the shoulder of this agent, what would you tell them to do, or what are they doing wrong, or how do they improve this conversation? Again, no wrong answers. Go for it.
Take control.
Take control. Be a little more assertive.
Tell
Okay.
them you're going to help them.
I like that. Yeah.
Yeah. Before I'm going to help you solve this.
Help
them. Then you can ask questions.
Absolutely. I like that. That would be my take is, you know what, stop asking so many questions. Say, hey, I've been there before. I know it's frustrating when you can't check out. I'm going to help you. That, however, is not what the algorithm told this customer, this agent. What the algorithm said is that their friendliness was really low, and specifically, don't apologize. Kind of weird advice, right? Don't apologize. Customer's pissed off. Why would you not? But so let me ask you, and this is the bonus question. Why would the algorithm recommend that they not apologize? How do we train this model? It's not, trust me, it's not that smart. I built it. No, it's good, but like it's not, you know, it sees outcome, it sees conversation. It's vectorized that conversation.
You're modeling it based on success. If you hear sorries, you're lowering your probability of success because sorry and success don't go together. So you automatically biased it by using the word sorry.
This is a good crowd. Well done. That is exactly the answer. And just, I'll repeat so everyone else can hear. Doesn't know causal inference. It doesn't know what came first or second. All it knows is that every time it sees the word sorry, that outcome tends to be bad, right? Low customer satisfaction score. Let's look at the list of words that it does not like. Worst keyword you can use as an agent. Number 1, inconvenience, apologize, sorry, delay, confusion, apologies, difficulty, hassle. Pretty straightforward, right? When it sees sorry, it doesn't know the sorry was because the customer was angry. All it sees is sorry, bad outcome, don't ever apologize, right? We learned this early on. Luckily, we were able to use causal inference and A/B testing to establish causality. For those who say, well, if it's a bot or a live chat agent, how much harm can it do? The answer is a lot. This is my favorite exchange of all time. This is someone on Twitter. Thank you, Indigo, for sending my baggage to Hyderabad and flying me to Calcutta at the same time. Brilliant service, hashtag die Indigo. And Indigo, the airline, responds, glad to hear it, keep flying, 6E. The user responds, are you serious? What are the odds he's going to be coming back anytime soon? So the subtext, the conclusion here is this. We're data scientists. I think we're equal part data and scientist. And I think we tend to focus on the data, especially lately, and not as much on the scientist. And what does it mean to be a scientist, right? You generate hypotheses and testable predictions. You gather data to test those predictions, and then you refine those hypotheses over and over again. So I think deep learning is really exciting. I don't want to sound like I'm opposed to deep learning. I think there's tremendous potential, and it can solve very, very specific types of problems. But it's, to a man with a hammer, everything looks like a nail. It shouldn't be applied to everything. And I worry more broadly that when we lose the how and the why, that we have potential to do some harm. Thanks.